Okay, for what we have regarding the angle between two non-zero vectors, u and v, and now if it turns out that, that we have for the formula cosine theta, if theta turns out to be 90 degrees, or in terms of radians pi over 2, you're going to have that u and v are going to be orthogonal, because at 90 degrees the inner product of u and v is going to be 0. And let's say that looking at the determination of the angle between vectors, and say if we have u to consist of 3 and 4, and the components for v we have 5 and negative 12, and for the inner product, this will be defined by the dot product of u and v, and so we have, again, the product, or taking the sum of the products u sub 1 v sub 1 and u sub 2 v sub 2. And with what we have given for u and v, so u with 3 and 4, v with 5 and negative 12, we're going to have for the dot product, we have the result of taking the sum of 3 times 5 and 4 times negative 12, or 15 and negative 48, which will be negative 33. And for what we have for the norm of u, now first of all we had to determine the inner product of u and itself, and so that's going to be the dot product of 3 and 3, 4 and 4 combined. So we have 9 plus 16 is going to be 25. So we have for the norm, or the magnitude of u, that is going to be the square root of 25, which will be at 5. And for looking at the norm of v, first of all we had to determine what we have for the inner product of v and itself. So we're pairing up 5 and negative 12 with itself and taking the dot product. So we have 5 times 5 plus negative 12 times negative 12, which is 169. And for the norm of v, that is going to be the square root of 169, which is 13. And now looking for the angle between u and v. So we have, again, for the cosine of theta, we're looking at the inner product of u and v divided by the products of the norms of u and v. So again, the inner product we had at negative 33, and for the product of the norms of u and v, we have 5 times 13, which is 65. So we have the cosine of theta is equal to negative 33 over 65. And for theta, that is going to be the inverse cosine of negative 33 65ths, and that's going to be roughly 2.103 radians. And in terms of angle measures, this will be about 120.5 degrees. Also, if we have in R3, say if we have that u consists of 1, 1, and 1, and we have for v, the v sub 1, v sub 2, v sub 3, we have it 2, negative 2, and 2. And we have for the inner product of u and v, so we're looking at u sub 1, v sub 1 plus 2, u sub 2, v sub 2 plus u sub 3 times v sub 3. And so for the inner product of u and v, so we have, again, so you have u sub 1, u sub 2, u sub 3 at 1, 1, and 1, v sub 1, v sub 2, v sub 3 at 2, negative 2, and 2, and taking what we have in compliance with the function. So u sub 1, v sub 1 is 1 times 2. 2 u sub 2, v sub 2 is 2 times 1 times negative 2. U sub 3, v sub 3 is going to be 1 times 2. And guess what? We're going to have 2 plus negative 4 is negative 2. Plus 2 is equal to 0. And guess what? Since we have the inner product to be 0, well, the cosine of theta is going to be equal to 0. And we don't even have to worry about the values of the norms of u and v, because the top part is 0. And for what we are going to have in this case, all right, so the inverse cosine of 0 is going to be pi over 2 radians, or in this case we're going to have at 90 degrees. And since we have the inner product to be at 0, we're going to have that u and v are orthogonal.